So thanks for everyone who's come today. It's a lot more people than I thought it was going to be. So please bear with me if I get a bit nervous on this. So for those who don't know me, I'm Darren Skinner. I'm a principal QA within the QA team. And today's talk is going to be on about putting your tests on a dial. So first of all, start a little bit about me and why you should listen to me. So I've been writing automated tests for 15 years. I've literally made every mistake you can possibly think of along the way. No doubt I will continue to find new ways of making these mistakes. But look, as long as you learn from them, it's not a total loss. We can all grow together. Someone a lot wiser than me once said, everyone makes a mistake, and that's part of the process. The talk is going to be about my top 10 testing tips. Technically it's 8, but if you want the other 2, you can speak to me after and buy me a drink. It's basically just a few things that I've learned over my time sort of writing automated tests that I think will help everyone. So to set the scene, I essentially think that we have 3 phases for any test that we write. We've got how the test starts, which is when we first write it. We've got what it becomes after constant refactoring and like little, adding coverage and things like that. And then we've got the third one, which is really what we want it to be. So to try and visualize this, I'm using, it's quite a tricky metric to get your head around, but we're using Ryan Reynolds. So your first one is totally shredded, totally unique. It's exactly what you want it to be. It's perfect. Then after time, you start making changes to your functionality. You start adding a few more assertions to it. You get just friends, right, Reynolds? Now this one's great. It does so much for you. It's always there. It's protecting you. It's a bit heavy. It's a bit slow. It's just not as shredded as it once was. What we want our test to be is epic, Reynolds. We want it to be dumb. We don't want it to be too smart. We want them to be incredibly powerful. And essentially, that's just it. They should be really simple to read, maintain, to run, but do everything that you need for you. A quick disclaimer on this. I'm going to be primarily UI focused, but a principle can be shared between nearly all tech stacks. And don't worry too much about whether or not this applies to unit or integration end-to-end testing. You can mix and match the lessons between all of the different phases. So the first one I've got, my first tip is you should only test one thing. So if you add too many assertions to your test, it can have a negative impact. Now, what do I mean by one thing? I'm not saying that every test should only test one unit of code in isolation. I'm not saying that every test should only have one assertion. What I am saying is that you should have one clear goal for your test. Now, if we look at an example of this, we've got a test that says you should be able to buy a ticket from London to Manchester. You've got your setup at the start, and then you've got a clear assertion. Search for a station, we select it with quick buy, we pay for it, and we assert that the ticket has been correctly purchased. Now, one thing that can happen, if you think back to the Ryan Reynolds slide, when we start adding things to the tests, we get a common pitfall, which is something like this. So we can see on lines 9 to 10, what we've done is we've taken our very targeted quick buy test, and we've now thought, well, actually, we'll just add another assertion to make sure that we can change the destination station. This test is now doing 2 things. So when you come to maintain it, you've got 2 different pieces of functionality to maintain. If you want to run this test, you have to run 2 different pieces, or 2 different goals. You can no longer say, right, just run me quick buy tests, because there's now a hard dependency between the 2. It will make life a lot easier if you can just keep the test to one goal. The next one we got is to remove unnecessary assertions. So if we look at this example of a test, we first start on the search results page. We expect ticket number 2 to be displayed. We expect ticket number 2 to be clickable. We then click it, and then we expect that the ticket is selected. Now, it seems logical. But if we look at the first assertion, for it to be displayed, and then we look at the second, for it to be clickable. Now, with modern tooling, a lot of these checks are done for you. So if we look at something like Playwright, one of the checks that it does is to make sure that every element is visible before it can be clickable. So actually, we don't need this line, because the to be clickable will do it for us. But then when we come down, we've got the click event. Now, we can never get to this click event if the to be clickable has failed. So again, there's no need for it. You can simplify this test, remove those lines. You've just got 3 lines of code that you have to maintain, and it makes execution quicker, and it's just less maintenance. Now, the one caveat to that people often say is, I put these different assertions in because I want to see exactly where it fails. Now, that's true, except for certain tools, like at least in the modern ecosystem, the click event will tell you exactly why it hasn't fired. So if it's not visible, if it's overlapped by something, if there's just no on-click handler, the click event will generally return you that error. If it doesn't, you know what? Your engineers, just write something that does it. Keep the test simple. The next one is test up to your boundary or keep off your neighbor's lawn. Now, what I mean by this is you don't want to bring more in. You don't want to bring more interactions into the test than you actually need in order to complete your one goal. So we remove all of the moving parts. It means the test makes the test easier to maintain, and it helps to decrease test execution time. So an example of this is we've got our single goal. We want to be able to submit a search from search widget with the correct origin and destination and date. We don't actually care that the next page is the search results page. For this test, all we care about is that when you submit the search widget, that you are actually submitting the form with the correct data. So at the top, we register a stub, which stubs out the search results page. Fill in the widget as normal, and then for our assertions, we call our stub, make sure that we have actually sent the correct information. Benefit of this, you don't have a dependency on any changes that come in for later on in the flow. Tests are much quicker because the stub will respond automatically. You can do a lot more sort of assertions around handling your code. My next one. If you don't need something, just get rid of it. Don't waste time on things you don't care about. So some examples for this: cookie consent. Now, I don't mean that we don't care about cookie consent. That would be a silly thing to say. What I mean is the cookie consent modal, especially on web, appears on every single page unless it's being dismissed. But if we're not specifically testing the cookie consent functionality, we don't really care if it shows or not. So we can drop a cookie on 99% of the tests. We save the loading time of the actual modal itself. We save the interaction time in dismissing it. And again, it makes our test a bit more sturdy and quicker to execute. Another example is if you're testing an after sales action, you need a ticket to be booked in order to perform that action against it. Let's just book, you can book the ticket programmatically via an API. You could inject data into the database. You could create mocks for your upstreams. It doesn't matter, you just don't need to use the UI to set state for your tests. Everything should be done programmatically if it's possible. And then the third one, which I really like, ads or analytics. They can massively slow down your page times and increase execution time. But again, if we're not specifically validating that ads or analytics work, block them, mock them, just kill them, get rid of them. Number 5. Now this one I love, and I very rarely do it myself, but I am really trying, is to define a max execution time for your tests, for each test and your suite, and stick to it. So if we look at our common setup, we've got tests running in parallel on a single build agent. Due to the resource, we can have 4 tests running at one time. And these are our tests. So we have 5 tests, which means we have to do 2 cycles. Our first 4 are all 30 seconds, and then spec 5 is our outlier at 90 seconds. How long will our execution time be? Well, depending on the runner used and the order of execution, it's either going to be 90 seconds or 120. So what we can do with this is break that big spec 5 down into 3 little 30-second increments. If we do that, we're still doing 2 cycles, but that second cycle isn't waiting 90 seconds, and the first cycle, and neither cycle is waiting 90 seconds for that to complete. We get a new execution time of 60 seconds. Let's save in 30 to 60 seconds, depending on how it executes in this example. You know, especially with UI tests, and they're quite slow. It wouldn't be, you know, it wouldn't be too much to expect that 30-second execution time to be in like a couple of minutes. So when you start to scale this, it really does help. But if things are still too long, what can we do? So again, similar setup. Tests running in parallel, 4 on a single machine. This time we have 20 tests. Again, they all take 30 seconds this time because we've cut them all down. So our total execution time is going to be 150 seconds. So the solution we've got is to use sharding. So what we're going to do here is going to scale functionality. We're going to use 5 virtual machines instead of 1. We're going to split the tests, and we're going to run 4 tests on each one. So what we have here is, so what we have here is a total execution time. Sorry, there's a mad delay. Right, you have a total execution time of 30 seconds. So on this one, we're saving, in this example, we're saving 2 minutes of runtime. Now, of course, like these virtual machines aren't free. They do, you know, they do cost money to run, but you're saving 2 minutes. And I would argue that it's better for you, it's better for the company to spend a little bit of money on cloud infrastructure rather than wasting your time looking at, you know, making you wait 2 minutes to start staring at a screen. Tip 6 is to make use of tagging. So what you want to do is break down your tests into logical buckets. So following on from the previous slides, CI/CD server has been set up for quick execution using sharding like we did before. Your local machine can't really compete with, you know, an infinitely scalable cloud infrastructure. You still want to run the test locally when you're developing a new feature, but you don't want to wait, you know, the 10 minutes it's going to take to run 4 tests in parallel with the limited resource of your machine. So tagging to the rescue. So if we tag our tests by the feature that they're testing, whether or not their execution time is slow or quick, by their priority, there's really anything you can do. Just any logical bucket that that you can think of to categorize your tests, so that when you do come to run them, if you're developing a feature for the search widget, you're not running tests that check the delivery options page. It's not needed. What you can do is run all of your tests locally while you're developing, and just get quick feedback on a targeted area. Tip 7 I've got is to make use of anything and everything to make your life easier. Basically, this is be lazy. Now, you can make your code reusable. So instead of copy and pasting between multiple different tests, abstract away, create helper functions, utils, whatever, but just reuse the same code over and over again. When it comes to do a big like refactor, it's much better to change one place rather than 100. Make your code shareable, and then this one is something that we really need to embrace, especially with our tests. We write a lot of test harnesses and some fantastic testing code, but historically it's always been isolated per repository. We should really start thinking, well, actually, is there anyone else in the company who will benefit from this test harness or this library? And then you can empower them to be lazy as well. Make use of snapshot testing versus expensive multi-level like custom assertions. I've seen it multiple times. I've done it multiple times where you'll put 50 different lines of assertions to check that an object is correctly returned. Just make use of a snapshot test, single line of code, easy to maintain, and it'll give you much better coverage. And then the same thing with visual testing. It's an incredibly powerful tool. Is there any need to write 2 or 3 lines of code to test 3 buttons when you could write 1 line of code, drop in a visual assertion and test the entire page? And in tip 8, and this is the most contentious of all tips, and this is the hardest one that I think that we're going to have to actually put into practice, is to test at the right level. What I mean by that is if we have a button component in React, you can provide it with 2 props, which is the text for the button to display and what happens when you click it. We have a unit test for the button that validates text prop is rendered and the event handler is executed. We also then have a component integration test that does exactly the same thing. And then once that button has been used in our application, we have a system integration test that does exactly the same thing as well. Now, it would be quite easy to say, well, we need to have the system integration test at the bottom, so let's just get rid of the other 2 and just have everything at that level. But then, as we can see, as you go further along to the system integration side, your execution time is going to be much longer, even though your confidence is going to be higher. There has to be like a happy medium. And I would love to sit here and to stand here and say this is the rule to follow, but it's not. Ultimately, you're going to know the application and the code better than anyone. Make a judgment call on it. Don't feel that you have to repeat and have tests at every single level. And if you need help, speak to your colleagues, come to the QA team. We'd love to be able to help you guys with that. So in conclusion, so testing doesn't have to be a chore. It's actually quite fun, and I'm biased, but I would argue I enjoy writing the test more than I enjoy writing, I ever have writing features. Embrace being lazy. I can't stress this enough. Embrace being impatient. You want quick feedback and you want it now. You deserve it. Make it happen. And you know what? Make mistakes, but make them once and learn from them. And if anyone has any questions, I'll be around. We've got a Help QA channel. Yeah, please come and speak to me. And yeah. Thank you.
I get a feedback bucket.